On a spring morning in late April of 1945, specifically the 28th day of that month, an American naval aviator found himself cruising through the sky above the East China Sea. Lieutenant Commander James Patterson had his hands firmly on the flight controls of a PB-4Y-2 privateer, a heavy bomber that droned steadily at an altitude of 15,000 feet. The aircraft maintained its course roughly 20 miles to the southeast of a Japanese naval formation, though Patterson and his crew would never lay eyes on those enemy vessels with their own vision. Inside the cramped fuselage, a radar technician hunched over his glowing screen, monitoring 4 small luminescent points that represented the Japanese ships below. Suspended in the bomb bay of Patterson's aircraft hung a pair of ASM-N2 Bat missiles, revolutionary armaments so advanced in their design and function that the sailors of the Imperial Japanese Navy remained utterly baffled about what exactly was striking their vessels, even after enduring multiple attacks from these strange new weapons. The radar operator's voice cut through the drone of the engines as he called out the relevant information, announcing that the target bore 045 degrees at a distance of 18 miles. These stark technical phrases would constitute the only human acknowledgement of the fact that actual living, breathing men crewed those distant ships, men who had been reduced in the American bomber to nothing more than glowing electronic signatures on a cathode ray display. Patterson would soon release his weapons, and those weapons would then navigate themselves toward their targets without any further human guidance, while his crew banked their heavy bomber toward home long before the enemy sailors even realized they were under attack. This represented warfare fundamentally altered at its very core, transformed not through displays of personal bravery or individual martial skill, but through American industrial might and the capacity to manufacture in quantity, these thinking weapons that stripped human agency from the equation of killing. The Bat missile marked humanity's initial venture into the realm of automated combat, a crude and primitive first step down a path that would eventually lead to the modern era of precision-guided munitions and unmanned aerial strikes against distant enemies. This particular guided weapon, the ASM-N2 Bat, held the distinction of being the world's first fully autonomous guided missile to actually engage in combat operations, having been developed by the National Bureau of Standards under the direction of a scientist named Dr. Hugh L. Dryden, who would in later years go on to serve as the first deputy director of NASA when that space agency was established. The critical difference between the Bat and earlier weapons, like the radio-controlled glide bombs that German forces had employed, was that the Bat operated with true autonomy, functioning as what military planners would later call a fire-and-forget weapon that utilized its own onboard radar systems to locate and strike targets without requiring any human intervention once it had been released from the carrying aircraft. The technical characteristics of this weapon represented a remarkable engineering achievement for the middle years of the 1940s. Each missile tipped the scales at 1,880 pounds and featured a wingspan measuring 10 feet across, while the warhead consisted of a 1,000-pound ANM-65 explosive charge. The radar seeker installed in the nose operated in the S-band frequency range and possessed the capability to detect large surface vessels at distances reaching up to 20 miles when atmospheric conditions proved favorable. The guidance system relied on analog computational methods, employing vacuum tube technology and servo motors that continuously made minute adjustments to the flight control surfaces, maintaining an optimal glide trajectory toward the point of impact. The genesis of this weapons program dated back to January of 1942, when officials within the U.S. Navy's Bureau of Ordnance recognized an urgent requirement for standoff weaponry capable of striking enemy warships from beyond the effective range of their anti-aircraft defenses. The National Bureau of Standards proceeded to assemble a diverse team that brought together aerodynamicists, electronics specialists from Bell Telephone Laboratories, and physicists recruited from universities scattered across the nation. By the time March of 1943 arrived, prototype testing had commenced at the Naval Air Station located at Patuxent River. What made the Bat truly revolutionary extended beyond merely its sophisticated technology to encompass America's industrial capacity to produce it in meaningful quantities. While German engineers struggled to handcraft small numbers of guided weapons in their factories, American manufacturing plants churned out approximately 3,000 Bat missiles, though operational circumstances meant that only around 420 of these weapons would actually be deployed to combat zones before the war reached its conclusion. The entire development program consumed $12 million, measured in 1940s currency, which translates to roughly $180 million in contemporary dollars, yet this expenditure represented less than 0.1% of total American military production during the war years. The Bat missile made its combat debut on the 23rd of April in 1945, when the Navy's VPB-109 squadron launched an attack against Japanese vessels anchored in Balikpapan Harbour on the island of Borneo. The mission failed to proceed according to plan, as both missiles launched during that initial attack suffered from technical defects and malfunctioned, serving as a stark reminder that even the most revolutionary weapon systems experience growing pains and reliability issues during their initial operational employment. Subsequent missions, however, would demonstrate considerably more success. 5 days later, on April 28th, the same VPB-109 squadron achieved what military historians would record as the Bat's first confirmed destruction of an enemy vessel, sending a Japanese patrol craft to the bottom in Balikpapan Harbour. The weapon had travelled approximately 9 miles from its release point to the moment of impact, and by that time the launching aircraft had already completed its turn and was headed back toward base when the explosion occurred far behind them. For the Japanese sailors aboard that doomed patrol vessel, death arrived from an apparently empty sky without any warning whatsoever, without the sound of approaching engines, without any visible attacker diving toward them through the clouds. The psychological impact of this new form of warfare exceeded by far the actual physical destruction that these early guided weapons inflicted. Japanese naval personnel found themselves completely lacking any conceptual framework for understanding what was happening to their ships. Their entire training and experience emphasized visual combat, ship-to-ship engagements conducted at ranges where you could see your enemy, and anti-aircraft defense against diving aircraft that you could track with your eyes and your gun sights. The notion of a bomb that could somehow see its target and think its way to impact existed entirely outside their comprehension, beyond anything their military education had prepared them for. To properly understand the significance of what the Bat missile represented, one must grasp the enormous technological chasm that separated American and Japanese capabilities by the time 1945 arrived. Japan had entered the war possessing certain areas of genuine excellence, including superior torpedoes, highly effective night fighting techniques developed through rigorous training, and well-trained naval personnel who understood their craft. Their Type 93 Long-Lance torpedo arguably ranked as the finest weapon of its kind anywhere in the world, boasting greater range and hitting power than any equivalent American torpedo. But while Japanese engineers focused on refining and perfecting existing technologies, American industry invented entirely new categories of weapons that had never before existed. The Bat incorporated miniaturized radar equipment, analog computing systems, gyroscopic stabilization mechanisms, and automated control systems, representing technologies that Japan not only lacked, but in many cases couldn't even conceptually understand how they functioned. Japanese engineers who managed to examine captured American radar equipment could identify individual components when they disassembled the sets, but they couldn't grasp how all these parts worked together as integrated systems to perform their functions. The disparity extended beyond mere technological hardware to encompass fundamental differences in industrial philosophy and manufacturing approach. American production methods emphasized standardization and mass production techniques, meaning that every Bat missile rolled off the assembly line using interchangeable parts manufactured to precise specifications that allowed any component to be swapped with any other of the same type. Japanese production, by contrast, remained largely artisanal in nature, with components being hand-fitted by skilled workers who individually adjusted each part to make it function properly. This fundamental difference in approach meant that America could manufacture complex guided weapons faster than Japan could produce conventional bombs using traditional methods. The historical record demonstrates that the Bat missile achieved modest but meaningful success during its relatively brief operational career. On the 1st of May in 1945, VPB-109 sent a second small vessel to the bottom, likely another patrol boat or some type of coastal craft operating off the coast of Borneo. The official after-action reports document this as a successful engagement against enemy shipping, though the precise type of vessel struck was never definitively identified. The most significant success achieved by the Bat missile program occurred on May 28 of 1945, when aircraft from VPB-109 attacked a Japanese escort vessel designated as Kaiboka Naguni operating in the waters near Okinawa. The Bat missile struck the warship squarely, but the vessel survived the impact and resulting explosion, though heavily damaged. Aguni managed to limp into port for repairs that would never be completed before the war ended several months later. While this attack didn't result in an outright sinking, it nevertheless demonstrated the weapon's potential effectiveness against defended targets, representing proper warships rather than small patrol craft. On the 18th of June in 1945, VPB-109 achieved its final confirmed kill of the war, sinking yet another small patrol vessel. Additionally, the squadron successfully destroyed at least one oil storage tank located on land, proving that the Bat possessed utility against stationary terrestrial targets in addition to its primary anti-shipping role. These three confirmed sinkings, all of them relatively small vessels, might appear modest when compared against the thousands of ships sent to the bottom by conventional bombing and torpedo attacks throughout the Pacific War. However, these kills represented something far more significant than their raw numbers might suggest, serving as proof of concept that warfare could be conducted by machines acting independently of direct human control once they had been released toward their targets. The other squadrons that received Bat missiles, specifically VPB-123 and VPB-124, failed to achieve any confirmed successes during their operational deployments. Their after-action reports describe numerous problems encountered during attempted attacks, including radar seekers that became confused by land masses appearing on their screens, humidity that damaged the sensitive electronics housed within the missiles, and difficulty distinguishing intended targets in congested waters where multiple radar returns appeared on the seeker's display. Crews frequently chose to jettison their missiles without attempting attacks rather than risk returning to base with armed weapons still hanging in their bomb bays. Analysis conducted after the war by the Joint Army-Navy Assessment Committee concluded that the Bat's effectiveness proved mediocre at best when evaluated against actual combat conditions rather than controlled testing scenarios. The weapon functioned admirably during testing against isolated targets positioned in open water far from land, but it struggled significantly in the complex environment of real warfare where multiple factors degraded performance. Radar clutter created by islands, interference generated by weather systems, and the primitive nature of electronics technology available in the 1940s all combined to reduce the weapon's effectiveness below what had been predicted based on test results. Yet even this limited success terrified Japanese naval personnel who encountered these attacks because they possessed no countermeasures whatsoever, no understanding of the underlying technology attacking them, and no effective defense they could employ to protect their vessels. Ships that survived being struck by Bat missiles submitted reports describing being hit from nowhere by weapons that provided no advance warning of their approach. The psychological impact generated by these attacks far exceeded the actual physical damage inflicted on the Japanese fleet. The Bat missile program symbolized in a very fundamental way the profound difference between American and Japanese approaches to warfare and weapons development. America could afford to invest millions of dollars developing a weapon that ultimately sank only 3 small vessels during several months of combat operations, because the investment advanced technology and operational concepts that would define future conflicts for decades to come. Japan, meanwhile, couldn't even conceive of developing such weapons given their resource constraints, much less develop effective counters to them once they appeared in combat. American production methods allowed for rapid iteration and continuous improvement throughout the development cycle. When early production BAT missiles began showing problems with humidity affecting the sensitive electronics, engineers quickly developed improved sealing methods and implemented them across the production line. When radar seekers demonstrated a tendency to lock onto land masses instead of ships in certain scenarios, modifications to the targeting algorithms improved target discrimination capabilities. Each problem identified in testing or combat led to rapid solutions that were then implemented across the entire production run. Japanese forces, by stark contrast, struggled simply to maintain their existing equipment in operational condition as the war dragged on. By the time 1945 arrived, fuel shortages meant that ships often couldn't put to sea even when their crews were ready and willing. Ammunition quality had degraded substantially due to severe material shortages affecting manufacturing, and the few radar sets that existed in the Japanese inventory frequently failed due to the lack of replacement parts and trained maintenance personnel. The technological gap separating the two nations wasn't merely about advanced weapons systems, but reflected basic differences in industrial capacity and organizational capability. Behind the BAT missile's development stood thousands of American scientists and engineers who approached warfare as fundamentally an engineering problem requiring technical solutions. Dr. Hugh Dryden, who led the National Bureau of Standards team responsible for the BAT's development, viewed the entire project through the lens of aerodynamics and control theory rather than military strategy in the traditional sense. His team included specialists in fields that had barely existed before the war began, including servo mechanisms, analog computing, and radar technology, all disciplines that were being invented and refined even as the war progressed. On the Japanese side, naval officers who had been trained in traditional forms of warfare found themselves facing weapons that negated their entire lifetime of preparation and professional development. The cultural emphasis on spiritual strength, warrior courage, and aggressive tactics meant absolutely nothing when confronted with weapons that could kill from beyond visual range without requiring any particular courage from the men who deployed them. The samurai tradition that heavily informed Japanese military culture at every level had no answer to offer against American industrial warfare conducted by machines. The BAT missile attacks created a unique form of psychological trauma among Japanese sailors who survived these encounters. Death in battle they understood perfectly well and had been trained to accept as part of their duty. But death delivered by invisible thinking weapons struck at fundamental beliefs about the nature of warfare and concepts of honor in combat. Survivors who were interviewed after the war reported experiencing profound confusion, helplessness, and a sense that they faced something that existed beyond the bounds of normal combat as they understood it. While the BAT missile represented the cutting edge of automated warfare, Japan responded to American technological superiority with the opposite extreme approach. The kamikaze special attack units represented human-guided missiles, sacrificing pilots to achieve what technology could not. Where America removed pilots from danger through superior technology, Japan turned pilots into weapons through ideology and cultural conditioning. This stark contrast illustrated perfectly the fundamentally different civilizational approaches these two nations brought to warfare. The kamikaze program, which was initiated by Vice Admiral Takejiro Onishi, explicitly aimed to counter American technological superiority through what Japanese leaders characterized as spiritual superiority. Onishi stated directly that Japan could not match American science and industrial production, but possessed something the Americans lacked, which was warriors genuinely willing to die for their cause. The parallel development of these diametrically opposite approaches, mechanical precision versus human sacrifice, came to define the final phase of combat in the Pacific War during its last desperate months. American sailors who faced kamikaze attacks experienced a form of terror remarkably similar to what Japanese sailors felt when confronted with guided weapons, as death arrived too quickly to effectively counter from attackers who couldn't be deterred by the normal human instinct for self-preservation. But where the bat represented the future trajectory of warfare, kamikaze attacks represented the last gasp of a martial tradition being systematically crushed by industrial modernity. The Bat missile operated within the larger strategic context of America's systematic strangulation of Japan through overwhelming technological superiority across multiple domains. Operation Starvation, which was conducted by B-29 bombers dropping magnetic and acoustic mines in Japanese waters, had by April of 1945 virtually eliminated Japanese coastal shipping throughout the home islands. Submarine warfare conducted by American boats had already destroyed the vast majority of Japanese long-range merchant vessels. The Bat missile added yet another layer to this comprehensive interdiction campaign that was strangling Japan's ability to wage war. While the Bat's direct contribution measured in terms of enemy vessels actually sunk remained minimal, its psychological impact multiplied the effectiveness of all American operations against Japanese shipping. Japanese ship captains became increasingly reluctant to put to sea even in areas where no bat-equipped squadrons were known to operate, because the mere possibility of a guided weapon attack added to the paralysis that was gripping Japanese maritime operations during the war's final months. American operational planners deliberately sought to enhance this psychological warfare aspect of the Bat missile program. Intelligence officers ensured through various channels that Japanese forces received information about the Bat missile and its capabilities, using captured documents that were allowed to fall into enemy hands, radio broadcasts that described thinking bombs in ominous terms, and ensuring that survivors from attacked vessels lived to spread fear and confusion throughout the fleet with their first-hand accounts. The Bat missile represented a remarkable technological achievement for its era, but simultaneously revealed the severe limitations of electronics technology available in the 1940s. The analog computer that guided each missile toward its target consisted of vacuum tubes that were inherently prone to failure, mechanical servos that required extremely precise calibration to function properly, and radar systems that could be easily confused by environmental factors beyond anyone's control. Operational success required near-perfect conditions to be present, including clear weather, isolated targets well separated from other radar returns, and electronics that continued functioning throughout the flight. These significant limitations help explain the weapon's modest combat record when measured in purely statistical terms. Of approximately 100 Bat missiles that were actually fired during combat operations, only a handful managed to achieve hits on their intended targets. The weapon functioned best against stationary or slow-moving targets positioned in open water well away from land masses that could confuse the radar seeker with spurious returns. Moving targets operating in congested waters near coastlines, or attacks attempted in poor weather conditions, often resulted in complete mission failure with the weapon missing entirely. Yet even this decidedly limited success in actual combat proved the fundamental concept underlying automated weapons. Every subsequent guided missile program that the United States military undertook built directly on lessons that had been learned from the Bat development and operational deployment. Engineers carefully identified critical technologies requiring substantial improvement for future weapons, including better radar discrimination capabilities, more reliable electronics that could withstand combat conditions, and improved servo mechanisms that required less precise calibration. The Bat functioned less as a finished weapon system ready for mass deployment than as a proof of concept demonstrating that automated warfare was genuinely possible with available technology. The final Bat missile attack of the war occurred on August 13th of 1945, just days before Japan announced its surrender to the Allied powers. Aircraft from VPB-109, flying from newly captured airfields on Okinawa, launched 2 missiles at what the crews believed were Japanese vessels operating in the area. Both missiles missed their intended targets completely, providing a somewhat fitting end to a weapon system that had promised far more than it ultimately delivered in combat, but nevertheless pointed clearly toward a coming revolution in how wars would be fought. By the time the war ended, approximately 420 BAT missiles had been deployed to the Pacific Theater, with only about 100 of those weapons actually being fired against enemy targets in combat. The remainder were carefully packed up and returned to the United States, where extensive post-war testing continued until 1948, when the program was finally terminated. These peacetime tests yielded results that proved quite disappointing to the engineers involved, ultimately leading the Navy to make the decision to remove the BAT from its inventory by the early 1950s, as newer and more capable weapons became available. Yet the BAT's perceived failure as a practical weapon system masked its genuine success as a technological demonstrator that proved concepts would be refined in future programs. Every American guided missile that followed in subsequent decades, from the heat-seeking Sidewinder air-to-air missile to the terrain-following Tomahawk cruise missile, incorporated fundamental lessons that had been learned from the BAT program. The engineers and scientists who had worked on the BAT's development went on to lead the development of Cold War missile systems that would define strategic deterrence for generations. Dr. William McLean, who had contributed significantly to the BAT's guidance system development, later went on to develop the Sidewinder air-to-air missile using basic principles that had been proven feasible by the BAT program. Military historians continue to debate the BAT missile's true significance in the broader context of World War II and subsequent weapons development. Its combat record, consisting of 3 small vessels definitively sunk, hardly seems worth the $12 million investment and the massive engineering effort that had been devoted to the program. Critics reasonably point out that conventional bombing and torpedo attacks achieved vastly greater results measured in enemy tonnage, sunk at substantially lower cost per vessel destroyed. A single successful mission by conventional torpedo bombers might sink more total tonnage than the entire BAT program managed to achieve during its months of operational deployment. However, this narrowly focused view completely misses what the BAT's true importance actually was in the long term. The program conclusively proved that guided weapons represented practical military tools rather than theoretical curiosities, that autonomous systems could function effectively in actual combat conditions, and that future warfare would increasingly depend on sensors and computers rather than individual human skill and courage. The BAT missile was the crucial first step toward the precision-guided munitions that would go on to revolutionize warfare during Vietnam, the Gulf War, and every subsequent conflict up to the present day. The BAT also demonstrated a characteristically American industrial philosophy that would define military procurement for decades, specifically the willingness to invest substantial resources in revolutionary technology even when immediate tangible returns remained uncertain or minimal. While Japan struggled desperately to maintain existing capabilities with dwindling resources, America freely explored entirely new categories of weapons that had never existed before. This fundamental approach to innovation and willingness to accept risk, perhaps more than any specific weapon system, ultimately determined the war's outcome at the strategic level. Japanese naval records surviving from 1945 reveal profound confusion about what exactly was attacking their ships when BAT missiles struck. Some reports describe what they interpreted as guided torpedoes approaching from the air. Other reports mention robot aircraft that could think for themselves. Still other documents contain speculation about death rays and other science fiction weapons that desperate minds imagined might explain the inexplicable. This fundamental inability to understand the nature of the threat made developing any effective countermeasures utterly impossible, even if resources had been available. Interviews conducted with Japanese naval officers after the war revealed the profound psychological impact that facing automated weapons had inflicted on professional military men. These officers readily understood and could accept being outproduced by American industry, being outgunned by superior American weapons, and being outnumbered by larger American forces. These were all conventional military disadvantages that fit within their understanding of how wars were fought and lost. But being killed by thinking machines that required no human courage to operate struck at truly fundamental assumptions about what warfare meant at its core. Several officers described in these interviews feeling that they faced not merely superior technology, but an entirely different conception of what war fundamentally was, as if the Americans were playing an entirely different game with different rules. The Japanese Navy's Technical Bureau did make genuine attempts to analyze this new threat they faced, but lacking any captured examples of the actual weapons or any real understanding of the underlying radar and computing technology involved, their efforts led absolutely nowhere productive. Proposals for potential countermeasures ranged from the marginally practical, such as deploying smoke screens to confuse radar seekers, to the utterly desperate, including suggestions for suicide swimmers who might somehow intercept the missiles in flight. None of these proposed countermeasures were ever actually implemented before the war reached its conclusion. The BAT missile's technological DNA runs directly through every modern precision weapon currently in military arsenals around the world. The fundamental concept of fire-and-forget engagement, where the launching platform can turn away immediately, autonomous target selection by the weapon itself, and standoff attack from beyond the range of enemy defenses, all originated with the BAT and its contemporaries. Modern anti-ship missiles like the Harpoon and the Exocet represent direct descendants of the BAT, incorporating the identical basic concept while employing vastly improved technology developed over subsequent decades. The ethical questions first raised by the BAT regarding automated killing, the removal of human decision-making from the application of lethal force, and the psychological impact of fighting against invisible enemies who strike without warning, all presaged modern debates about drone warfare and autonomous weapons that continue to this day. The BAT represented the first weapon in human history to kill enemy personnel without requiring any human guidance whatsoever after the moment of launch, crossing a threshold that military ethicists and philosophers continue grappling with 80 years later. For the United States Navy, the BAT provided absolutely crucial lessons about the future development of guided weapons that would be applied to every subsequent program. The critical importance of reliable electronics capable of functioning in harsh environments, the necessity of effective target discrimination to avoid wasting weapons on wrong targets, and the requirement for operational simplicity that allowed average crews to employ the weapons effectively, all emerged clearly from careful analysis of the BAT's decidedly mixed combat record. These hard-won lessons informed every subsequent missile program undertaken by American forces, ultimately saving years of development time and millions upon millions of dollars in wasteful spending. The BAT missile program's final statistics reveal both the magnitude of achievement and the sobering reality of its limitations when measured against initial expectations. Total production reached approximately 3,000 individual units manufactured. Of these, 420 units were actually deployed operationally to combat zones. Roughly 100 of those deployed weapons were actually fired against enemy targets during combat operations. Confirmed enemy ships sunk by BAT missiles totaled exactly 3 vessels, all of them relatively small patrol craft. Ships damaged but not sunk numbered 1, specifically the escort vessel Aguni. The total program cost reached $12 million, measured in 1945 currency. Development time from initial concept to first combat employment spanned roughly 3 years. These raw numbers demonstrate a weapon that achieved extremely limited tactical success, measured in enemy vessels destroyed, but simultaneously achieved enormous strategic importance by proving concepts that would define warfare for generations to come. The 3 small ships that the BAT managed to sink pale into insignificance when compared against the thousands of guided weapons programs that directly followed in its wake and built upon its technological foundation. For the Japanese sailors who found themselves facing this revolutionary new weapon, the BAT represented utterly incomprehensible technology that completely negated everything they understood about naval warfare from their training and experience. Death arrived from apparently empty skies, delivered by machines that could somehow see in complete darkness and think faster than any human brain could possibly process information. These men were the very first warriors in all of human history to face truly automated weapons operating independently. and their confusion and terror marked humanity's entrance into a new age where wars would be fought as much by algorithms and computers as by individual soldiers with rifles. The Bat missile cannot be credibly said to have won the Pacific War for the Allied forces. That ultimate victory came through the combination of overwhelming American industrial production that could not be matched, superior logistics that kept forces supplied across vast oceanic distances, the island-hopping campaign that steadily approached Japan, and ultimately the deployment of atomic weapons against Hiroshima and Nagasaki that forced surrender. But despite not winning the war, the Bat clearly showed what the future of warfare would inevitably become. The trend would move toward precision rather than mass bombardment, toward automation rather than individual courage, toward technological superiority rather than warrior spirit and martial traditions. Every guided missile, every smart bomb, and every armed drone employed in modern conflicts traces its direct lineage back to those first primitive radar-guided weapons that were released over the Pacific Ocean during the spring and summer of 1945. In the present day, as heated debates continue raging about autonomous weapons and the ethics of increasingly automated warfare, we find ourselves still grappling with the same fundamental questions that were first raised by the Bat missile 8 decades ago. When machines can independently select and engage targets without any human intervention after initial launch, who exactly bears moral responsibility for the deaths that result? How do professional warriors maintain meaning and purpose in their service when advancing technology steadily negates the importance of individual human skill and courage? What happens to the fundamental nature of warfare itself when the act of killing becomes mathematical and algorithmic rather than personal and immediate? These profound questions, first posed in practical terms by an 1,880-pound glide bomb guided by primitive vacuum tube technology, remain largely unanswered even today as the technology grows ever more sophisticated. The Bat missile achieved remarkably little when measured strictly in terms of enemy ships destroyed and removed from Japanese naval order of battle, yet it nevertheless opened a door into the future that can never be closed again, regardless of any treaties or agreements that might be signed. The age of thinking weapons had irrevocably begun, and warfare would never again be the same as it had been throughout all of previous human history. The Japanese sailors who died without ever seeing their attacker, without even understanding what kind of weapon had struck their vessels, were the very first casualties of this new age of automated warfare. Their confusion and complete helplessness when facing incomprehensible technology that operated beyond their ability to comprehend presaged the experience of every soldier since who has found themselves targeted by precision-guided weapons launched from beyond visual range. These men discovered, in the most terrible and final way possible, that the future of warfare would belong not to the bravest warriors willing to sacrifice everything for their cause, but rather to the nations that could field the smartest weapons guided by the most sophisticated technology. The Bat missile flew into the history books carrying far more than simply 1,000 pounds of high explosives in its warhead. It carried with it the end of one entire age of warfare, and simultaneously the beginning of another fundamentally different age, an age that we are still living within today, still attempting to fully understand its implications, and still struggling to maintain control over the technologies we continue developing. In that larger historical sense, the humble Bat missile, with its decidedly modest combat record of 3 small vessels sunk, but its truly magnificent implications for the future of human conflict, may well have been the single most important weapon system developed during World War II, that almost nobody outside of military historians and weapons development specialists remembers or knows anything about today.